Learners, this is Dr. Krishnaveni giving you a lecture on LCM of numbers, methods to find out LCM of numbers, LCM of decimals, and GCD and LCM of fractions. This lecture is for the Unit 2, fractions, GCD, LCM of numbers. LCM means the least common multiple. So let us start with an example. See, here you are finding out LCM of two numbers 4, 6. So what we need to do here is first we must find out the multiples of 4. Here M stands for multiples. Multiples of 4 means 4 table. 4, 8, 12, 16, 20, so on. Infinity number. Multiples of 6 you have to now write. So the multiples of 6 are 6, 12, 18, 24, 30, so on. Now you need to pick up the common multiples of 4 and 6. So among these multiples of 4, multiples of 6, we have here common multiple means here 12 is common to both and 24 will be common to both. 36 would be common to both. Okay, if you write the multiples of 4 table, you will get 24 because 4 6 are 24 and you get 36 because 4 9s are 36. Okay, and 6 6 are 36. So these are the common multiples of 4 and 6. Here instead of 10 you must write 6. And then you pick up the least common multiple. In case of GCD, you picked up the greatest common divisor. Now you're picking up the least common multiple. Of these common multiples, which are infinite number, 12 is the least one. Okay, now you see the LCM of 5 and 10. First, you write the multiples of 5. These are all multiples of 5. 5 1s, 5 2s, 5 3s, 5 4s, 5 5s. So, infinitely many are there. And multiples of 10. 10 table. 10 1s, 10 2s, 10 3s, like 10, 20, 30, 40, 50. These are all multiples of 10. What you need is common multiples. See, common multiples. So, the common multiples are 10, 20, 30, like that. Okay, of these common multiples you must identify the least one. So the least common multiple is 10. Therefore for 5 and 10 the least common multiple is 10. So this method is again tedious and time consuming also. So we follow certain methods to find out LCM of numbers, especially when the numbers are in big numbers. So see, LCM of two numbers is the least common multiple of them, and these are the different methods of finding out LCM of the numbers. One is the factorization method, other one is common division method, and here common division method is actually preferable to find out LCM of numbers. Okay, especially when the numbers are large. Okay. Now, first method is factorization method. So what you have to do is, you have seen already how to find out GCD of two numbers using factorization method. Here also what you have to do is, you have to express each of the given numbers as product of prime powers, and then what you have to do is, you have to select the common prime factors. There also first two steps are the same, and when you are writing GCD, what did you do? You picked up the least powers. Okay, now to write the LCM, after writing the common prime factors, you have to pick up the highest powers. Okay, and then find the product of those you get to get the LCM. So the process is the same. This is called as factorization method. In case of GCD, after writing the given number as product of prime powers, both numbers, then you picked up the common prime factors. There you took the least powers. Here you are taking the highest powers. Okay, so the product of common factors with highest powers will give you the LCM, whereas the product of the common prime factors with least powers will give you the GCD. So that's why I start with the factorization method. See here, LCM of these two numbers. What did we do there? Like you have to factorize 18 as product of prime powers. What are the prime numbers here? 2, 3 and 7. And here 21 is also another number and it is factorized as product of prime numbers. So the common prime numbers are, you have to write 2, 3, 7. Here 2, 3, 7. Here there is no 2, so 2 power 0. Here there is no 7, so 7 power 0, because any number to the power 0 is 1. Okay, so finally 18 is written as product of three different prime powers, whereas 21 is also written as product of the same three prime powers. Okay, now you must write the common primes. What are the common primes? 2, 3, 7. If it is GCD, you must pick up the small powers, least powers, and when you are finding out LCM, you have to pick up the highest powers. Here 2 power 1, here 2 power 0. The highest one is 2 power 1. And for 3 it is 2 power, and for 3 it is power 1. So you must pick the highest power whenever you are finding out LCM. So 3 square. And for 7 power 0, 7 power 1, 1 is the greater number, so 7 power 1. So LCM of these three numbers is, you must find the product of this. 2 power 1 is 2, 3 square is 9, 7 power 1 is 7. The product is this. That is what it is explained. The only difference here is, after writing the numbers as product of prime powers, you write them as in common primes, and when to find out the GCD, you pick up the least powers, and when you have to find out LCM, you pick up the highest powers. Here 2 power 1, 2 power 0. GCD means you will take 2 power 0. LCM means you have to take 2 power 1. And if it is GCD, 3 square, 3 power 1, so you have to take 3 power 1. And as you are writing LCM, you took 3 square. And when you are writing GCD, here it is 7 power 0 you must take, because 0 is the least power. But you are now writing LCM, so you have to pick up the highest power. Okay, the procedure is the same. Only thing is, you have to pick up highest power in case of LCM and least power in case of GCD. This is another example. You can go through it. Okay, LCM of two numbers. 24 is expressed as product of prime powers. 16 is expressed as product of prime powers. Here there is 2, 3. Here there is 2, 3. To get LCM, you must write the common prime factors. 2 and 3 you must write. And here power of 2 is 3. Here power of 2 is 4. Pick up the highest power, 4. Here the power of 3 is 1. Here the power of 3 is 0. Pick up the highest power, 3 power 1. So 2 power 4 is 16. 3 power 1 is 3. 16 3s are 48. So this LCM of 24, 16 is 48. This is the first method, which is factorization method. Now let us go to the common division method. I will explain to you through a problem. Afterwards, we'll come back to the step-by-step process. See, here we have 4 numbers and we have to find out LCM of these 4 numbers. Okay, so what you do is you arrange them like this. See, that is the first step. Arrange the given numbers in a row. Okay, in any order you like. So I arrange these numbers and in a row. What is the next one? Divide by a number which divides exactly at least 2 of the given numbers. Okay, and carry forward the numbers which are not divisible. See here, 12, 20, 32. All these numbers are divisible by 2 because they end with 2, 0. Okay, so of these 4, 3 of them are divisible by 2. So you put here 2, and 2 6 are 12. 2 10s are 20, 2 16s are 32. But here 45 is not divisible by 2. So you carry forward that. That is what step 2 means. Okay, so which number to take means it depends. If at all there are 2 and more than 2 numbers divisible by one particular number, you can take that. Okay, so here now 45 is not divisible by 2. You have to carry it forward like this, 45. Now you have 6, 10, 16, 45, and among these 4, first 3 are divisible by 2. So you take 2 now. 2 3s are 6, 2 5s are 10, 2 8s are 16. Because 45 is not divisible by 2, you take it as it is. Okay, and means it will be carried forward. Okay, now we have 1, 2, 3, 4 numbers again, and of these 4 numbers, these number 5 and 45 are divisible by 3. Whereas this 3 is also, no, 5 and 45 are divisible by 5. And here we have 3 and 45 are also divisible by 3. So either you can go for 3 or 5. So let me take 3 now. 3 ones are 3 and it doesn't divide 5. So 5 will be as it is written here. It is carry forward like that. Okay, you just carry it forward. That's all. Okay, and 3 does not divide 8. So you carry it forward. That's all. It because 3 does not divide 8. And now 3 divides 45. How many times? 15 times, because 3 15s are 45. Okay, in see 5 and 45 are divisible by 3. That's why I took 3. That is what this step means. Divide by a number which divides exactly at least 2 of the given numbers. Okay, it can be more than 2 numbers like in the previous steps, but here in this case, third step, only 2 of the 4 numbers are exactly divisible by 3. That's why I took here 3. Okay, and those numbers which are not divisible by 3, here there are 2 numbers like 5 and 8. You just carry them forward. Okay, now you have again how many numbers? 4 numbers. Of these 4 numbers, you see any 2 of them are exactly divisible by a particular number. See, if you take 5 and 15, both of them are exactly divisible by 5. That's why I took it here 5. Okay, so now 5. So here 1 is not divisible by 5. So you have to write it as it is. 5 ones are 5. See here 5 is divisible by 5. So 1. So 8 is not divisible by 5. So you carry it forward. Keep it as it is. And 15 is divisible by 5. 5 threes are 15. So now you have a stage here where see you see here 8 and 3. These two are not divisible by a particular number. Okay, that's what he says. You repeat the same process, and how long, till no two numbers are divisible by the same number except one. Okay, so the same situation you got here. These two numbers are divisible by 1. So you have to stop it, and other 2 numbers are not divisible by any other number like before. Okay, so there ends the process. So what you have to do is you find product of all these numbers to get the LCM of this, like 2 into 2 into 3 into 5 into 1 into 1 into 8 into 3. Okay, then that will give you the LCM of the given numbers. So now the product of the divisors and the undivided numbers will be giving you LCM of the given numbers. One more example. See, you have 4 numbers here and you are asked to find out LCM of these 4 numbers. So you arrange them in a row in any order you like. 15, 27, 36, 50. That is the first step. And you see if at all any 2 or more than 2 numbers are exactly divisible by a particular number. See, the first 3 numbers are divisible by 3. That you must know by using divisibility rules, which you did in first unit. So now 3 5s are 15, 3 9s are 27, 3 12s are 36, and 3 does not divide 50. You just keep it as it is, means you carry it forward. That's all. That's what the step says. Okay, and now of these 4 numbers, if you see, this 9 and 12 are divisible by 3. 2 more than 2 numbers are divisible by a particular number. That number you have to put here. So these things you will be able to identify and do only when you're thorough with the divisibility rules which you learned in the first unit. Okay, so now 3 does not divide 5, so 5 will be carried like this, and 3 divides 9 3 times. 3 3s are 9, 3 4s are 12, and 3 does not divide 50, so 50 will be carried forwarded like this, is carried forward like this. So now you have again 4 numbers. You see 5 and 50 are divisible by 5. Okay, of these 4, these 2 are divisible by 5. So take here 5, 5 ones are 5, and the 5 does not divide 3. So 3 you have to just carry it forward, and then 5 does not 4. 4 you carry it forward, and 5 divides 50 10 times. 5 10s are 50. So now of these 4 numbers 1, 3, 4, 10, these 4 and 10 are divisible by 2. So you put here 2. Now 2 does not divide 1. So 1 is carried here, 2 down, and 2 does not divide 3. Keep it as it is. You carry it forward. and 2 divides 4, so 2 2s are 4, and 2 divides 10, 2 5s are 10. So now if you see, these numbers are not commonly divisible by any other number, so there ends the process. Okay, you have to proceed like this. If at all at least 2 of these numbers are divisible by a particular number, otherwise you have to terminate the process. So to write the LCM of these 4 numbers, you find out the product of all the remaining numbers and the divisors. Okay, 3 into 3 into 5 into 2 into 1 into 3 into 2 into 5 will give you 2700. So the LCM of these 4 numbers is 2700. So you have seen how to find out LCM of numbers without decimals. Now, like in case of GCD, here we have LCM of numbers when there are decimals. Okay, so what exactly we did then, same way you have to proceed here also. First of all, you check whether the decimal position is at the same place in the given number. If the decimal place is not in the same place, what did I say? In that case, the same thing you have to follow. Here you see that the decimal position is in the same place. How? By annexing zeros in the numbers. And afterwards, you must consider the numbers without decimal point. And then find out the LCM of those numbers without taking into consideration the decimal. And after finding out the LCM of those numbers by those methods which you learned just now, you first get the LCM and afterwards you mark off decimal position as there are in each of the given numbers. Okay, so the same procedure like you did in case of GCD. So first find out whether the numbers are having the same decimal position at the same place, and afterwards if they are not having the decimal place at the same position, you have to see that all the numbers are having the same decimal place by annexing zeros, and without considering the decimal position and place, you have to find out the LCM, and afterwards you have to mark the decimal. Okay, now let us see this with an example. So here you have 3 numbers, girls. In the number 3, if you see, there is no decimal position, and 2.7 there is a decimal position after 1 place. You must always come from right to left. And here 0.09, if you take, in this number there is decimal place here after 2 places. Okay, the decimal is placed after 2 places. Okay, so the position is here after 2 places, the position is here after 1 place, and there is no decimal. So that is why first step is what? You have to see that the decimal position is at the same place in all the numbers. So that's why what I did is here 3 I wrote it as 3.00. 2 zeros I included here, annexing zeros I said no. So why? Because 2 zeros. Why? Because after 2 places you must have decimal position. So here 2.7, after 2 places you must have no. So one zero here I included, so that 2.70 is same as 2.7 only. These two are equal. Now the decimal position is here after 1 place, whereas the decimal position is after 2 places. Okay, now here in 3.00, 2.70, 0.09, the decimal position is the same at the same place after 2 places. Now remember, 3.00 or 3 both mean the same. 2.70 or 2.7 both mean the 0. Both means the same. So here, but what we did here is, as a first step, all these 3 numbers are having the decimal place at the same, decimal position is of the decimal is at the same place. Okay, so now that is the first step. What is the second step? After getting the numbers with the same decimal position, you have to take the numbers without the decimal. That means here without decimal means 300, without decimal means 270, without decimal means 009. 009 is same as 9. Okay, now here you have 3 numbers and there is no decimal. Like we discussed no in previous slides, you can find out the LCM of these 3 numbers either by division method or common division method or by factorization method. Okay, So here I'm finding out LCM of these three numbers by common division method. So these numbers are all divisible by 3. So 300 is 300, 390 is 270, 3 is 9. Again except, see these two numbers are divisible by 10. Or you can say 90 and 3 are divisible by 3. You can either divide with 3 or divide with 10. It is your choice. Okay. Now I did here division with 10 and the first two numbers are divisible by 10. I said exactly in the second step, if at all two or more than two given numbers are divisible exactly by some number, you just divide those numbers by that number. Okay, now 10 tens are 100, 10 nines are 90. Now if you take these three numbers 10, 9, 3, 9 and 3 are divisible by 3 exactly. So you divide with 3 and this 10 will be carried forward. Okay, you carry 10 forward because it is not divisible by 3. Okay, see here also 10 does not divide 3. So what I did here is 3 is now carried here forward. Okay, so here 3 does not divide 10. You keep it as it is in the next, that means you have to carry it forward. And 3 3s are 9, 3 1s are 3. Now here if you see 10, 3, 1, there are no common factors for these. Okay, so that's why you stop the process. Now to get LCM, what you have to do, you find the product of all the divisors and all the remaining numbers. So 3 into 10 into 3 into 10 into 3 into 1, which will give you 2700. So LCM of these numbers is 2700. But the question is to find LCM of not these numbers, to find the LCM of these numbers. So what you have to do is you just put decimal position after two places. So 2700, but all these numbers are having decimal position after two places. So after two places means 27.00. So the answer for this question is 27. So actually you have seen how to find out LCM of two numbers without decimals and with decimals. Now you are going to find out a relation between LCM and GCD of two numbers. Okay, see here is the relationship between them. Product of two numbers is exactly equal to the product of LCM of the numbers and GCD of the numbers. Okay, so A into B, if at all you have two numbers, A into B is equal to product of GCD of AB and LCM of AB. And now how to find out product of GCD of fractions and GCD of LCM of fractions. Okay, you have seen already how to find out GCD of numbers and GCD of decimal numbers and LCM of ordinary numbers, LCM of numbers with decimals. Now you are going to find out GCD of fractions and LCM of fractions. Here is the formula. GCD of fractions is you find out GCD of numerators and you find out the LCM of denominators, divide this with this. Okay, to find out LCM of fractions, you find out LCM of numerators and you find out GCD of denominators and divide LCM of numerators with GCD of denominators. Okay, so just now you have seen all the procedures of finding out GCD and LCM. So just like that you find out the GCD and LCM, use the formula to get the GCD and LCM of fractions. Okay, here is an example. See here in the first question you have, see, find the GCD of these numbers, which is this much, and the same numbers you are finding out LCM. Okay, so GCD of the fractions means what you have to do is first you find out the GCD of numerators and LCM of denominators. So numerators are here 12, 18, 21. So numerators are 12, 18, 21. See here I did this by factorization method. You write 12 as product of prime powers like I explained to you in the previous slides. 18 also product of prime powers like I explained to you in the previous slides. And 21 is product of prime powers. See, in all these prime factorizations, 2, 3, 7 are prime numbers and they are common to all these numbers. When you are writing GCD, what you have to do, I said you must write first all prime numbers, and to write GCD, you have to write the least powers. And here in these three numbers, the power of 2 here is 2, power of 2 here is 1, power of 2 here is 0, the least power is 0. Whereas when you are writing LCM, you have to pick up the highest power. So in all these, the highest power is 2. Okay. So next GCD of next 3 is the power of 3 here is 1, power of 3 here is 2, power of 3 is here 1. Least power you must take into consideration whenever you are writing for GCD, and highest power, that is 2, you must write whenever you are writing for LCM. Okay, next 7 is also there as one of the factors, and the least power of 7 is 0 because it is 0 here, 0 here, 1 here. So when you are writing for GCD, you must take the least power of this, and when you are writing for LCM, you have to write the highest power. See here, only thing is in factorization method, everything is common. To write GCD, you write all the common prime factors and you write the least powers of them. Whereas when you are writing the LCM, you first write all the prime factors which are common in all these numbers and you pick up the highest powers. That's all. So 2 power 0 is 1, 3 power 1 is 3, 7 power 0 is 1, product is 3. And here 2 square is 4, 3 square is 9, 7 power 1 is 9, product is 252. So for numerators, we found out GCD and LCM. Now let us consider for this problem the denominators 25, 35, 40. So the denominators are 25, 35, 40. Like I explained to you before, you find out the GCD of denominators, LCM of denominators. So now what is the formula? GCD is of the fractions is GCD of numerators by LCM of denominators. So here GCD of numerators is 3 and LCM of denominators is 1400. So GCD of these numbers is 3 by 1400. Very simple it is. Now to find out LCM of the fractions, what you need is LCM of numerators by GCD of denominators. So here you got LCM of numerators, which is 252, and you need GCD of denominators, which is GCD of denominators, which is 5. So the answer is 252 by 5. So to find out GCD and LCM of fractions, you need to find out GCD of LCM of numbers for numerators and denominators and use the formula. Very simple it is. If you just go through it, you will be able to understand. So now we will see some applications of what we learned so far. See here, find GCD and LCM of these decimals. I explained to you already, no? See, first step is to find out GCD or LCM. What you have to do is, you first check whether all these numbers are having the decimal place same decimal place, means at the same position. Okay, see here, for the first number, the decimal position is after 2 places. Second number, the decimal position is after 1 place. And for last number, there is no decimal place. What you have to do is, you have to annex zeros to make the numbers with the same decimal places. So 2.8 means after 2 places you need, no, like in this case, so you annex 1 0. So 2.8, 2.80 both are same, whereas here the decimal is after 1 position and here decimal is after 2 places. Okay, and when 4 you have take 4 as 4.00 and 4.00, the decimal is after 2 places. Now in all these 3 numbers, the decimal is after 2 places. That is the first step, whether to find out GCD or to find out LCM. So what is the next step? As per the step-by-step process, you must consider the numbers without decimals. See, 0.16 without decimal means 0.16. 2.80 without decimal means 280. 4.00 without decimal means 400. Okay, now you have 3 numbers, and in all these numbers there is no decimal place, and 0.16 is same as 16. So for these numbers you find out GCD, for these numbers you find out LCM, like we discussed in previous slides. So GCD of the numbers, you got it as 8 for these numbers, 8, and LCM of these numbers you got it as 2800. Okay, so what we discussed, after finding out GCD of the numbers and LCM of the numbers without decimal, you must see that the decimal position is again put in the GCD and LCM. So here after 2 places you have decimal position, no? So 8 after 2 places means you must see from right to left I said to come. So 0.08. This is the GCD of the given numbers. And if you for this LCM also after 2 places you have to put decimal. So it becomes 0, 0. Here you have to put 0 point. So 28 is the answer. That is the LCM for the 2 given numbers with decimals. Okay. Next question is, see here we have to make use of whatever you learned, the applications of the GCD and LCM. See here GCD of 2 numbers is given and their LCM is known to you. So one of the numbers is also given. Then they ask you to find out the other number. There are 2 numbers. You know only one of the numbers. You know their GCD and LCM. So what is the other number? I discussed in the previous slides that product of 2 numbers is equal to product of their GCD and LCM. This is a very, very important formula. So here 2 numbers you don't know, only one number is known to you. So let it be A and you have to find out B. Okay, you substitute for A, that is 220, and he gave you the GCD of 2 numbers as 15. So in place of GCD of 2 numbers, you put it as 15 and then into, and you have what? LCM of 2 numbers, and LCM of 2 numbers is given as 2200. Okay, in this equation, you put for A 220 into, and B you have to find out, you keep it as it is equal to, and then GCD of 2 numbers AB is given as 15, you substitute that here, into is there, and LCM of 2 numbers 2200, you substitute it here. Okay, so your aim is to find out B, the other number. Okay, so you keep B on the left side only, and 220 you take to the right side of the equation. As it is in the numerator, it will be reversed when you take it to the other side. So 15 to 2200 by 220 comes. So after simplifying this, you get the answer as 150. Okay. So one of the numbers is known and their GCD you know, their LCM is known. So you are able to find out the other number just by using this formula. Next question is again related to the same formula. Here in this case, the product of 2 numbers is given and their GCD is given, and you are asked to find out LCM. Okay, so product of 2 numbers A into B is known to you, that is 384 is equal to, and product of their GCD actually is known to you, that is 8, and you are asked to find out their LCM. So this is the unknown thing now. See, A into B is known to you, GCD of 2 numbers is known to you. Only thing is you are asked to find out LCM of 2 numbers. So you must know what formula to be used as per the hypothesis. Okay, so after substituting, you must find out LCM of 2 numbers. No, you keep it this side, you take 8 to the other side. When it goes to the other side, it goes to the denominator. So 384 by 8, because it is in the numerator 8 now, you're taking that to the other side of the equation. So it goes to the denominator. So 384 by 8 gives you 48. That is the answer. Next question is find GCD and LCM of the 3 numbers. So already we discussed this, and now see 3 numbers or 2 numbers, same procedure. First you find out the GCD of the 3 numbers either by using the division method or by using the factorization method, and afterwards you find out the LCM of the 3 numbers either by using common division method or factorization method. Okay, so here we did the GCD, we found out GCD using the factorization method, and also LCM by using the factorization method. And then for GCD, what I said, for GCD, after writing the prime powers here, you pick up the powers with least. Okay, here 2, 3, 5, 7, they are common in all these numbers. So you write 2 into 3 into 5 into 7. To write GCD, you must pick up the small powers, and to write LCM, you must pick up the big numbers. See, like this. See here 2, 3, 5, 0, 1, 1, 0, 0 are the small numbers, whereas 3, 2, 2, 1 are the bigger numbers. So GCD of the given numbers is 6 and LCM of the given numbers is 12600. Now another problem is find out the GCD and LCM of the fractions, which was already discussed. So there is a formula. GCD of a fraction is GCD of the numerators by LCM of the denominators, and GCD of the LCM of the fractions is LCM of the numerators by GCD of the denominators. Okay, so first write the numbers in the numerators, for which you have to find out both GCD and LCM. Then you write the numbers in the denominators, for which you have to find out both GCD and LCM. So GCD of the fractions, I gave you a formula which is equal to GCD of the numerators by LCM of the denominators. So GCD of the numerators, you got it as 1, and LCM of the denominators, you got it as 1260. So 1 by 1260 is the GCD of the fractions. Now LCM of the fractions formula is LCM of the numerators by GCD of the denominators. So LCM of the numerators is given by 360, and GCD of the denominators is given by 1. So LCM of the fractions is 360 by 1. This is how you can find out GCD and LCM of the given numbers, whether they are ordinary numbers, whether they are in decimal form, whether they are fractions. Thank you.